All right, so let's begin with our class. So in previous classes, we saw something like this: solving equations, and since these equations have an exponent of 2, we know this equation as a quadratic equation, right? So we've seen this in the past. Now we are going to learn how to solve these equations in the complex number system. It is exactly the same, but the way you write the answer changes a little bit. So let's start with something really simple. X squared equals 4. How would you solve this? Absolutely easy, right? Just isolate the variable x. Change the exponent into a root on the other side of the equation. If we do that, we're going to have that x is now the square root of 4. But we know that square roots can be positive or can be negative, right? Of course, we also know the square root of 4 is 2. So we know positive 2 and negative 2 is going to be the solution. In this case, we have two solutions, right? Negative 2 and positive 2. Remember, this little sign means instead of having just one answer, we have two. One with the negative sign and another with the positive sign. This is why we have positive or negative. Always, no matter what grade or what subject, whenever you have this sign, positive or negative, plus or minus, this means you have two possible solutions, one negative and the other one positive. Beautiful stuff here. Let's do this one with a little bit with a little bit more of an increased difficulty. Let's try question B. How would you guys solve this? X squared equals negative 9. All right, if we just take the same approach as the one before, all we have to do is isolate the variable, right? So this 2, which is an exponent, we're going to change it into a root in the other side of the equation. So we know x is going to be the square root of negative 9. Always roots are going to be positive, but can also be negative, so positive or negative, square root of negative 9. The question is, what is the square root of negative 9? And please, all right, please don't say it's negative 3. No, negative 3 is not going to work. Because if you multiply negative 3 times negative 3, if you multiply by itself, negative and
3i
negative will
to
be
the second
positive.
power.
3, kind of, something like that. Yes, I have no idea who that was, but something like that. Something like that. You are on the right track, brother. You are on the right track. Something like that. Instead of saying that this root is negative 3, this is what we're going to do. We remember that roots with negative numbers inside can be solved if we take advantage of what we learned with complex numbers. We know that I, the letter I, is the imaginary unit, and I is the square root of negative 1. So this negative 9 can be split into two, negative 1 and 9. So we have the square root of negative 1 times the square root of 9. This is the square root of 9 times I. Look at that. We just took the negative of the root. We took it outside of the square root. Outside. The square root finishes here in the 9. This I is outside of the root. Also, we have it positive and negative, so we carry these two signs. The solution will also be positive or negative. Now, this square root of 9, we know the solution, right? We know the solution. We know how much is the square root of 9. That thing is 3. So we know the solution is going to be either positive 3i or negative 3i. In this case, this equation had two solutions, negative 3i and positive 3i. Again, the positive and minus, this one, positive and negative, means we have two solutions, one positive and the other one negative. Beautiful stuff. From here, we have a couple of things to know, right? If you like to take notes, go ahead and write this as a note. Since these equations are quadratic equations, meaning the exponent is 2, since these equations are quadratic equations, we have two solutions. Always two solutions, right? One with the positive sign, the other one with the negative sign. Always two solutions. If you have three, then we have a mistake. If you have just one, then we have a mistake. We have two solutions. All right, let's increase the difficulty a little bit more. From here, we have a quadratic equation as well. This is x squared minus 4x plus 8 equals 0. This quadratic equation is one of the ones we used to work with in the past, right? This is the way you solve this. We recognize that this is a quadratic equation. And since it is a quadratic equation that we need to use the quadratic formula. Remember, this one, I said it at the beginning. You guys are going to have to use this all the way to 11th grade. And some of you that are going to college, some of you are going to have to use this even then. All right, so this is one of the things that we learn in mathematics, and we memorize them because we just keep on using this. All right, we just keep on using this. But how do we use it? For the people who don't remember, how do we use this equation? How? It is absolutely simple. All we have to do is change the values of B, A, and C. We change these values for the coefficients in the equation. Here is how. We know that A is the coefficient 1. We have it as ax squared, this one. Since there is nothing here, we know the coefficient is 1. For B, we know the coefficient is -4. Remember, these numbers are not only the numbers, are also with the signs. So this negative goes with the number. This is part of the coefficient. -4 is the number. And C, which is the number that doesn't have a variable, the constant number. We have it as +8, so +8. Beautiful. Now that we have the values of A, B, and C, all we have to do is put it here in the formula. Replace the values. If you do replacements, this is what you're going to have. You have -4, double negative. Why? Simple. One of the negatives is the one of the formula, and the other negative is the one of the coefficient. So we have negative, double negative. From here, plus or minus, the square root of B squared. That is 16 because we have -4. So -4 squared will be 16. All right. Minus 4 times A times C. So 4 times 1 times C times 8. All right. Over all of that over 2A. So the denominator will be 2 times A. A is 1, so 2 times 1. If we do these calculations right now, we have that we have minus and minus will be positive, right? So we have positive, 4 plus or minus the square root of -16. Here, inside of the root, we have the -16, right? And all of that over 2. Now, just like we learned when we were dividing numbers, we have to split this denominator, right? But before we split the denominator, we have to take care of the root. We have the square root of 16, -16. Well, that thing is for I, right? Remember, the negative inside of a root can be changed into an I. So we are left with the square root of 16, which is 4. Roots are positive and negative, so there we go. We have the positive and the negative sign. Now that we are here, we can split the denominator. We can create 2 fractions, right? The denominator is going to go under this 4, but also under this other 4. So we have 4 divided by 2 and 4 divided by 2. This is going to be the solution then. 4 divided by 2 is 2. 4 divided by 2 is 2 as well. So we have 2 plus or minus 2i. Remember, we have 2 solutions. So in this case, the equation, the main equation, this one from the beginning, this equation, since it was quadratic, we have then 2 solutions. One with the negative sign, look, 2 minus 2i, 2 minus 2i, and the other one with the positive sign, 2 plus 2i, 2 plus 2i. Those are going to be our 2 solutions for the main equation. Remember, guys, always we are going to have 2 solutions. Now, the question is, can you guys recognize the characteristic between this number and this one over here? These two numbers have something in common. They do. They have something in common, don't they? Can you explain me? Can you explain to me in the chat, please? Just write it in the chat. How did you call these numbers? Let's see who gets it first. What if I help you with these? All right, so Vale Moreno are saying these are roots. All right, these are kind of roots, not really, because this is in the complex number, in the complex system, but there could be roots in the complex plane, so maybe. Lau Valentina Botero say complex. All right, yes, these are two complex numbers. They are, but this complex number and this complex number have one characteristic. Look at this. This one is negative and the other one is positive. Everything else stays the same. We have a name for that. When we keep the real part and the imaginary have its sign changed. How do you call that? Alejandra Rico, congratulations. You got it, woman. These two are conjugates. This number is the conjugate of this, and this one is the conjugate of this other one. And that will happen with every single solution of quadratic equations. Both solutions will be the conjugates of each other. Also here, look at the previous example. Look, in the previous example, in this equation, one is the conjugate of another one. Even in the one that have real numbers. No, in the one that have real numbers, that doesn't work. Only with the ones of conjugates of quadratic equations. All right. That I find that amazing, because that is just something that we mathematicians were not expecting. This is a happy coincidence, and it is amazing. All right. Quadratic equations in the complex number system. Absolutely simple. Again, all you have to do is use the formula, replace the values, and then take out the negative root as an I. From there, everything is the same. Now for the new topic of today. Oh, by the way, yeah, design means we have the solutions. Now, for the new topic of today, let's continue with polar coordinates. What are these? No way! What is this? All right, this is something you haven't seen in the past. This is something entirely new. But just like with everything new in mathematics, we are going to begin little by little. Don't worry about this new word, polar. Don't worry about this. Coordinate, man, I don't know. Do you mean these are coordinates in a plane? What is this? Don't worry about that for a sec. Let's think about something that we do need for this new topic, but something that it is absolutely easy. Absolutely easy. Let's begin with radians. Now, I feel like you don't really know what are radians. I feel like you haven't really used radians in the past. Some of you might be saying right now, radians, what is that? All right, don't worry. If that is the case, all you have to understand from today is that radians is a different unit of measure for angles. All right. In the past, we have been measuring angles with degrees. Remember the little ball, the little circle in a corner of the number? So if I want to say 45 degrees, I say 45 in a little circle. That is a unit. Angles, just like regular numbers, have units, right? And just like regular numbers, we can measure angles with different units. One of those units is degrees, but another, a different unit, is radians. Right? Radians are a different unit. All right. Now, just like we have formulas to change from centimeters to feet, or from feet to kilometers. Just like we have formulas for that, we have formulas to change from radians to degrees. We have those formulas. And we use those formulas that we have it over here. These are the formulas that we have here, right? So let's say we want to change from radians to degrees. From radians to degrees. Which equation do you feel like you would use? Are you going to use the first one? This is number 1. Or the second one, number 2? Write it in the chat, please. Number 1 or number 2? Again, if I give you radians and I ask you to change it to degrees, number 1 or number 2? All right, we have 3 people answering, 4 people. All right, thank you. Beautiful. 9 people now. All right. Thank you to all of the people who answered the question. Yes, you guys are correct. Now, don't be scared if you make mistakes. If some of you would have said, teacher, we used to, or teacher, I'm not understanding anything. It is okay. I can explain it again. All right. But give it a try. Try to answer. So yes, guys, you are correct. We are going to use the first formula. Now, I haven't explained the formula, so it was kind of a difficult question, right? But we can also try to understand it, read it, and analyze it. And we know that the degrees is equal to radians being multiplied for something. So the solution here will be degrees. If I give you, if we use this formula to change degrees from radians, then that wouldn't make much sense, would it? Because the solution is degrees. This is the end. At the end, the result will be degrees. So this equation number 1 is used when we take radians into degrees, right? Simply replace the word rad for the amount of numbers, for the amount of radians, right? Multiply by 180 divided by pi, and there we go. We have the solution. Now, this rad is the unit for radians. So instead of having to write radians, you can just say rad, and that is okay. That is correct. All right. That leaves us with the second one. The second one works to change degrees into radians, and it works in the exact same way. Just put the number instead of degrees, multiply by pi, divide by 180, and the solution will be the amount in radians. Now, all of this is easily said, but the more we practice, the better we are going to get at this. This is one of those exercises that we are going to have to use calculator for. All right. So what I want you to do right now, guys, here, we are going to do all of these exercises, but you want to have your calculator. So hopefully you have it with you. If you don't, you can just use the one in your cell phone. That is okay. Now, by the count of 5, I want you to please grab your calculator. I'm gonna give you up until the count of 5 for you to grab your calculator and have it with you. 1, 2, 3, 4, and 5. All right, let's begin. So we have the first one, right? Question number A, 60 degrees, and we want to change it because that's the question here. Convert from degrees to radians. We want to convert 60 degrees. Remember, the little ball, the little circle in the corner means degrees. Change from 60 degrees into radians. But how do we do this? We remember that the formula is this one over here in the corner, right? This is the second formula. So instead of the word degrees, we are going to write down the amount in degrees. So instead of degrees, we have 60 multiplied by pi over 180. 60 multiplied by pi over 180. The word radian is just there because the solution will be in radians, right? We take these, we put it in the calculator, and we have our solution. Now, before we do this, we can simplify this fraction. We don't have to if that is not what the question says. If the question says simplify, then we do have to simplify. But over here, it just says convert, right? So we can just put this in the calculator. However, if you want to simplify it, this will be the simplified version, right? Just simplify 60 and 180. carry the pi. That's it. 60 over 180 is 1 over 3. So 1, nothing, right? 1 over 3. This is the perfect answer. This is the absolutely perfect answer. But if we want to round this, we just put pi over 3 in the calculator. Now, before I show you the real answer, I want to see how much do you think this will give you. Write it in the chat, please. How much is pi over 3? A little bit of water. Oh, beautiful. All right, we have some answers now. Let's see. We have Brian who says 1.047. Lau Botero, 1.05. Rad. Wow, radians. Man, you did not forget about the units. Beautiful, Lau. And then we have some more. Let's see who gets the answer. And then I'm going to say who got it right or who got it wrong. Here. So the solution will be 1.047 radians or rad. So congratulations to Lau Botero, Juliana Parra, Vale Moreno, Brian Jimenez, right? Danny Capella, Joshua, Lau Anzola, and Juan Andrés Rodriguez. Congratulations, guys. You have it correct. This will be the solution. Perfect, guys. Now, take a look at something. Sometimes I use the equal sign because what comes next is the same as before. It is equal as before. These two things are the same. They are equal. Same here. Equal because these and these are equal things. But this sign, this is not the equal sign, is it? This is the sign used for approximations, estimations, rounding, something that is not equal but is kind of, is really close to. So knowing when to use equal and when to use this sign over here is extremely important in mathematics. If we said that pi over 3 is equal to 1.047, then we are making a huge mistake because that is a lie. Pi over 3 is not exactly 1.047. It is not. If you look at your calculator, you have more decimals there. More decimals, right? An infinite amount of decimals. So no matter how many decimals you write, what you write, the solution will not be equal to the question. That is exactly why I'm writing this. And that is what you have to do to use as well, guys, right? Remember, equal means the two things are the same, but this one means what comes next is an approximation, all right? Let's continue with question B, 150 degrees. Change this into radians. All right, so to do this, we use the formula, right? Instead of degrees, write the 150. So 150 times pi over 180. Pi over 180. Whack this into the calculator, and then we have the solution. But if we want to simplify it before, we can simplify 150 and 180. The simplification will be 5 over 6. Again, this is the exact solution. So I'm saying this about the exact solution. I'm saying this because sometimes the book asks you to find the exact solution. So sometimes all you have to do is simplify, all right? In some books, this exact solution is also called leaving the answer as a multiple of pi. That is what it's called in some books. Leaving the answer as a multiple of pi. So just, you know right now, from now on, you know, if the answer says, leave the answer as a multiple of pi, then you know the pi has to appear. And what you have to do is just simplify. But if it doesn't say so, if the question doesn't say so, just like in this case, we can round. So let's say, how much will be 150 in degrees into radians? Write it in the chat, please. All right, we have some solutions. Beautiful. We have some solutions. All right, the solution will be 2.618 radians. Congratulations to Vale Moreno, Lau Anzola, Lau Botero, Juli Parra, Samuel Cáceres, Samuel Méndez, sorry, Brian Jimenez, and Julian Vega. You guys are correct. Also, Julian, remember to, Julian and Samuel, remember to round the number. Look, if you just say 2.61, right? Then you're cutting the number without rounding. The next number is an 8. So this one changes to a 2. Changes to a 2. All right? So, yeah, make sure you round, guys. Don't forget about rounding. Rounding can give you or take 1 unit from you. All right? So remember to round. Beautiful. Let's continue with the next one. We have a negative number. Yes, we can use negative degrees and change these into radians. The process is exactly the same. Take the negative 45, change it for the word degrees, whack it in the calculator. But before we do that, we can also simplify. Negative 45 over 180. This will be negative 1 over 4. That is why there's nothing here, because we have 1 over 4. This will be the perfect, the exact solution, the multiple of pi solution. But if we want to round it, let's see who gets it in the chat. How much would this be? Negative 0.785 radians. Congratulations to Vale Moreno and Juan Camilo Alba. All right, also Lau Botero, Brian Jimenez, and Juliana Parra. Also, Brian, don't forget about rounding, brother. 0.785. All right, the next number was a 5. So don't forget about rounding. You need to round. Now, this could happen, maybe to some of you, if you didn't use the key pi, but instead of pi, you wrote 3.14, 3.14, then the solution may have mistakes, may have some errors. All right? So don't use 3.14 for pi. Don't use that number. Pi is not 3.14. In your calculator, you can find the word, the key, sorry, for pi. You can have the key for pi. It's a little blue key. You find the key, and if you use the blue part of the key, the alpha, or is it? Yeah, I think it's alpha. Alpha and then the key. Then you're going to have the pi, all right? Beautiful. Now, look at this. We had the negative degree, so now we have the negative radian. The negative carries, right? It's exactly the same. Let's continue with 90 degrees. This one, if we put it in our formula and we simplify, we're going to have pi over 2. Look, 90 over 180. We know how to simplify, right? So the solution will be pi over 9. 90 is pi over 9 radians. Half pi. And if we put this in the calculator, the rounder number will be, all right, 1.571 radians. Let's see who gets it correctly. We have a lot of people now. Juan Camilo Alba, you are correct. Julian Andrea Parra, Vale Moreno. Oh yes, Samuel Méndez, Lau Valentina Botero, Aleja Rico, Juan Andrés Rodríguez, Laura Valentina Anzola, and Dani Valentina Capella. Beautiful, guys. You guys are correct. And you didn't forget about rad, the units. Beautiful, guys. Last but not least, let's see who gets it first. 170 degrees into radians is exactly 1.868 radians. Congratulations to Aleja Rico, Julian Andrea Parra, Lau Botero, and Camilo Alba. Beautiful, guys. Oh, Juan Camilo, you forgot about your dot, right? 1 point something. Beautiful, dude. 1.86. Beautiful. Yes. So this is the answer. Now, 1.87, right, Juan Camilo? Look, the next number was an 8, so round your solutions. Guys, you're going to have a quiz today. You may do this correctly, do this process correctly, but writing the answer is also important. If you say the answer is 1.86, the quiz will be wrong. You are going to fail that question. All right? 1.87 is the correct rounding. All right, guys? It is not enough with knowing how to use the formula. Would you also have to know how to write the answer? Beautiful. All right, this is how to change from degrees to radians. But at the beginning, I said we have two formulas. One is from degrees to radians, and the other one from radians to degrees. This is exactly what we're going to do right now, changing all of these radians into the degrees form. To do that, we remember that there is a formula for that. We are going to use this little formula here. Instead of the word rad, we are going to write down the amount of radians. So if we do that, we are going to have pi over 6, which is the radians, is going to be pi over 6 times 180 over pi. The word degrees is just because at the end, the solution will be in degrees. But look at this. These type of questions can, most of the times, be done without using calculator, because we can do this even in our heads. Even in our heads. Look, pi and pi are going to get canceled. So the solution will be 180 divided by 6. 180 divided by 6. So how much is that? All right, 180 divided by 6. This is 30. This is 30. We know how to divide this to 180 divided by 6. This is 30. And then we put the degrees, right? The little circle, the little ball on the corner of the number. Here will be 30 degrees, just like that. Let's go with the second example. 3 pi over 2. Put it instead of rad, replace it for rad, and do this exercise, right? Here, we can cancel the pi, and we will have 3 times 180 divided by 2. Again, we can do this in our heads. We can do this. This will be 360 divided by 2. But if we cannot, if we don't want to, we can still use the calculator. So how much is this, guys? In the chat, please. 3 pi over 2 radians is exactly beautiful, guys. Beautiful. 270 degrees. 270 degrees. Beautiful. I think I had a mistake at the beginning here. I multiplied by 2 instead of 3. All right, guys, beautiful. 270 degrees. Congratulations to Vale Moreno and Lau Anzola. Beautiful, guys. You had it first. Let's continue with the next one. Look, a negative amount of radians, a negative number here. The solution, will be negative as well. Just put it instead of radians in our little formula and do the multiplications. Negative 135 degrees. This, at the beginning, the question was negative. The solution is negative as well. D. You guys are going to do D now. Let's see who gets it first. How much is 7 pi divided by 3 in degrees? I can wait. Okay, I have 2 answers now. Anyone else? 3 answers. Don't forget about the units. All right, I think that is enough. I think that is enough. Beautiful. So we just put it in the calculator, right? Cancel what we can cancel. Simply press enter, and we have 420 degrees. 420 degrees. 420. Congratulations to Aleja Rico, Vale Moreno, and Samuel Mendez and Marino Moreno, kinda. Right? Samuel, brother, you forgot about the units, huh? You need to do the little circle on top of the number, 420 degrees, all right? If, guys, please write this down somewhere as a note. I didn't have this in the presentation because I forgot, honestly. But this is important stuff here. if the number is without the little circle, so let's say I have 420 here without this little circle, without the degrees. If that is the case, then what are the units for the number? The number is in radians then. All right? Remember, if I don't write down the little circle, that means the number is in radians. All right, guys? From now on, a number without units is a number in radians. Meaning, Samuel, your answer will be in radians. All right? And Marino Moreno, it looks to me that you didn't know how to do the little circle in the corner. So that's okay. I mean, we can all learn. Look, right under, if you look at the keyboard, if you look at the keyboard, right under the escape, right, the escape key, there is a little key that if you do shift and that key, it will give you the little circle on top. All right, Marino? All right, okay, beautiful stuff. Last but not least, let's see who gets it first. How much is 3 radians into degrees? Juan Camilo Alba got it first. The solution will be rounded to, again, rounded to, sometimes we cannot cancel and then the answer will be in radians. I'm sorry, it will be a round answer. 171.89. Congratulations to, where is it, Juan Camilo Alba, who gets it first. Now, Vale Moreno also got it correctly. Juliana, Andrea Parra got it correctly. Lau Anzola correctly. Juan Vega. I mean, that is a correct rounding, but dude, come on, use a little bit of the decimals, all right? And Tomas Ramirez, you also got it correctly. It's okay. Don't worry, dude. I understand. It's okay. All right, beautiful stuff here, guys. Congratulations to all the people who actually tried these exercises with me. And thank you for giving it a shot, for giving it a try. All right. Things to know here. Remember, the equal sign only used when the answer is perfectly rounded. The answer is exactly the same here. Equal, 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 equal. In this case, we have a lot more decimals. We have an infinite amount of decimals. So we use the round sign. How do we know that? Because there is a pi here, right? 3 times 180 over pi. At the end of the day, the pi has infinite decimals, so the solution will have infinite decimals. The only reason why in these ones, in all of these ones, we didn't have infinite decimals is because we could also cancel the pi. Like the pi and pi, these two get canceled. Pi and pi get canceled. These two also get canceled. So we didn't have the problem with the infinite decimals at the end, right? But in this case, we don't have something to cancel the pi with. So we're going to have to carry with the infinite amount of decimals. To do that, just round the number. Beautiful. From here, guys, that was the class for today. That was the class. That's it. That is it, guys. What I want you to do right now is jump into the practice, all right? So I'm going to stop the recording here, and we're going to get to work on these exercises, guys. Thank you.